Recently I had an industrial design and manufacture job where I needed LED covers. 3D printing this thin-walled part was a challenge, and after not being satisfied with the results from using both auto-generated supports and modelled supports, I decided to try machining the surface. First on the manual lathe, then on the CNC router. The lathe had potential, but it was not easy to get the parts spinning concentrically, and obviously it was a manual process. On the CNC machine, the part could be quickly and easily probed in using macros I had written previously. Getting the toolpath dialed in with a slight negative stock to leave value took some trial and error before getting a successful recipe. The results on this print have some imperfections where the supports were connected due to the part having such a thin wall. I found that even if the entire surface is machined back, there are artifacts in the 3D print where the supports connected. This may not be an issue for non-translucent prints. In summary, for CNC machining 3D prints, it certainly is a valuable solution for manufacturing using 3D printing where supports are required on visible surfaces, especially where batches of parts will be produced and or where a consistent finish is required. This method should also provide good results for cleaning up print lines where you may be able to print fast at 0.3mm layer height then machine back the surface instead of printing at high quality 0.15mm. Being a light duty operation on the CNC router, a 3D printed work holding jig for this operation would suffice, and so I designed and printed this work holding jig that clamps from 4 sides with M8 screws. This is a 2D contour toolpath with smoothing turned on and negative 0.1mm stock to leave. Looking at the G-code produced, you can see it's using G2 or G3 arc feeding moves that are much smoother than the jerky G1 interpolated toolpath. The cutting tool is a Datron ball end mill single flute 6mm. The completed unit is a desk light pole used to indicate the status of a help desk phone call. The customer opted for a carbon fibre tube and the base was custom designed for their desks. I used the Loft tool in Fusion 360 to create this nice organic shape that looks great, 3D printed in eSun Black ABS. Here are some of the R&D test units with aluminium extrusion. The LED cover was printed in eSun Clear ABS. I used the Loft tool here as well to join the center ring body to the 2 end bodies. With careful measuring and compensating for thermal shrinkage, I was able to get this unit to be assembled with friction fits, only requiring 2 fasteners for the base clamp. With the USB cable running up the inside of the carbon fibre tube, the unit has a clean, professional look. Considering the cost of custom designing and manufacturing this unit versus adapting an off-the-shelf unit, it was competitive in price, especially considering the customized final product. Okay, well that's it for that project. While I was producing this video, I searched online for CNC machining 3D printing, and I found a couple of good web pages on Stratus's website, so I'll link to those in the description. But the basic takeaway from them was they say you have to add extra material to your 3D print, obviously to machine away, that may be obvious, and you can achieve better tolerances using CNC machining than you can with 3D printing, so you get the advantages of that. And they've got a couple of examples of the work they've done machining 3D prints as well, so if you found this interesting, then maybe you should check that out as well. But yeah, I'll leave it there for this video. If you found that interesting or entertaining, please consider subscribing, and I may follow up this process in future with some more examples of what we can do with this. So please subscribe, and I'll catch you in the next video. Cheers, bye.